right? And then the other thing we got to understand for next semester and this semester, we'll do some problems on it this semester, but really this will become critical next semester when we do interference and stuff, is we finally have to talk about what's going on with the phase, right? Phase is the hard part of waves, and I can prove it to you with science fiction. Phase constant, and then phase difference. These are three different things. Okay? So anytime you watch science fiction and they want to need something magic to happen, but they want to justify it with a little bit of sciencey sounding words, what word do they always use? One. The word one. Okay, sometimes they use the number one. Quantum, yes. And what comes after quantum? Phase, right? They don't ever say in terms of amplitude or radius, because you're going to know they're bullshitting you. Like, oh, I know what amplitude is. You can't be here and then suddenly be over there because you changed your amplitude. Give me a break. But if you say phase, oh yeah, well maybe. And that's because nobody understands what phase is, okay? So let's talk about the three kinds of phase, okay? So let's go back to the string because it made sense, I guess, right? A sine kx minus omega t plus this phi naught. And I should have been putting a naught on it every time. I may not have been. Thank you. Okay, here we go. So the three differences, right? The entire argument under the sign, or the argument of the sign, is the phase, okay? So one big misconception is that this is the phase. This is the phase constant. The whole thing is the phase. Because phase just means where you are on a sinusoid, or how much you change your position on a sinusoid. Am I at the positive maximum? Am I at the negative maximum? Am I at the zero? Am I halfway? That's going to depend on all these things, right? On the wave, it depends on where you are and when you are and what your initial phase was. Okay, so phase, whole thing. Okay, this phi naught is the phase constant. Okay, so say you want to adjust where zero is, or you want to have some, say if you have a certain k and a certain omega of a wave and you work it out and it's not in the right place at the right time, but all you need is to adjust it a little bit, you put in a phase constant. You put in a constant number there, and that lets you adjust it. We're not really going to calculate these, I don't think, this semester in this class, but it'll come up next semester. So I just want you to know what it is. Just a constant that doesn't depend on time or space. Okay. The third one, so technically we could write this one also this way, is the absolute phase. The phase without the phi is kx minus omega t plus phi naught. Just to make it clear, it's the whole thing.